This video lesson is on calculating compound events in probability. Have you ever wanted to play the lottery? Do your parents play the lottery? The lottery is just compound probability. For this lesson, we're going to cover standards from both the Math 7 and the Math 8 curriculum because it asks for you to calculate compound probability in both of those. You do need to know that there are two types of compound events. The first is independent. This is easier to calculate. Independent probability is just two separate events, kind of like what we've been doing in class with simple probability, and the two events will just be in the same problem together. Dependent tends to be a little bit more complicated. The first event in dependent is going to affect what happens in the following events. So like when you are playing the lottery and you pick a number, you can't reuse that number, so it affects the other numbers that you can pick. And we'll look at some lottery tickets in class, and the numbers get really large really quick, so we'll have to use the graphing calculators to do that. Here's our first example of an independent event. This is where you have two separate events that have no effect on each other. What is the probability that you select a red pencil from a pencil pouch and a green M&M from a bag? So if you look, here's my pencils. There are 7 of them. 1 of them is red, so the probability of getting a red pencil is 1 out of 7. If I look at the M&Ms, I've already counted the total. There's 23 of them. 2 of them are green, so 2 out of the 23 M&Ms are green. That's what we've been doing in class. Because this is now one situation and you want to know the combination of the 2 of them, we're going to multiply them together. To multiply fractions, we multiply the numerator, so we're multiplying straight across, and then we're multiplying straight across in the denominator. And that would be our probability of both of those events together. Here's another example of an independent event. What is the probability that you select a yellow pencil, a red M&M, and an orange marble? So again, I have 1 of my 7 pencils are yellow. If I'm looking for red M&Ms, 4 of the 23 are red. And if I'm the marbles, 3 of the 12 marbles are orange. So there's my 3 separate simple probability. And to make it compound probability, we're just going to multiply our fractions together. And again, we're going to multiply straight across in the numerator, straight across in the denominator. And then when you come into class tomorrow, we will go over how to simplify this fraction so that it's always in simplest form. Here's our last independent event. What is the probability that you will select a yellow M&M, replace it, and then select a blue M&M? I've already counted. There are 8 yellow M&Ms out of the total of 23. You don't like yellow M&Ms, so you put it back, and now you're trying to get a blue M&M, and there's 2 of the 23 are blue. We're going to multiply our fractions together, and again, multiply straight across in the numerator, and then straight across in the denominator, and that would be the fraction that represents the probability of those 2 events together. Dependent events, you need to think what's happening when you write your second or third or fourth fractions. So here's our first example of a dependent event. What is the probability that you select a red pencil from your pencil pouch, not replace it, and then select a green pencil? So here's your pencil pouch. 1 of the 7 pencils are red. Somebody in class forgot their pencil, and you are so nice that you let them use your red pencil. But now you need to get a different pencil out of your pencil pouch. But there's only now 6 pencils in your pencil pouch, and you want to try for the green one, so that's 1 out of now 6 pencils. So there's our 2 simple probabilities, and again, we're going to multiply them together to make it compound. And that would be the probability of getting a red pencil, not putting it back in your pouch, and then getting a green pencil. We're going to look at the M&Ms again. What is the probability that you select a yellow M&M, you eat it, and then you select a blue M&M? So again, the probability of getting a yellow M&M is 8 out of 23. So you pick out this yellow M&M, it's so good you eat it. So now you're trying to get a blue M&M. There's 2 blue M&Ms, but because we've eaten this yellow M&M, that means we only have 22 M&Ms left. So 2 are blue, but there's only 22 left. This is where you have to think when you're dealing with dependent events. But again, once you know your 2 fractions, we're going to multiply them together. You multiply straight across. And then again, in class tomorrow, we're going to talk about how to write your fractions in simplest form. What is the probability that you select a yellow M&M, eat it, and then select a blue M&M, eat it, and then select a red? So again, this is dependent because we're not putting the M&Ms back. So we're going to start with the first one, yellow M&M. 8 of the 23 are yellow. You're going to eat one of them though, so this one is going to go away. Now we're trying to look for the blue M&Ms. There's 2, but now I only have 22 M&Ms. Now I want to try to get a red M&M, but I've now eaten one of the blue M&Ms, so this M&M is going to go away. Now I have 4 red M&Ms, but because I've now eaten 2 M&Ms, I am now down to 21 M&Ms. Multiply your fractions together. Again, we're multiplying straight across the numerator, and then we're multiplying straight across the denominator, and then you should write your fraction in simplest form, which again, we'll practice tomorrow. Here's our last example of a dependent event. What is the probability that you will select a yellow M&M, eat it, and then select another yellow M&M? Again, the probability of yellow M&Ms is 8 out of 23. There's 8 yellow M&Ms out of the total of 23. But I'm going to eat this yellow M&M. So now I want to try to get another yellow M&M, but I've eaten one. So that means I only have 1, 2, 3, 4, 5, 6, 7 yellow M&Ms. And again, because I ate one, that also means there's only 22 M&Ms left in total. So this time, because we were trying to get a yellow a second time, both of our numbers in our fraction had to change. So multiply your fractions together, and then you need to write your answer in simplest form. I hope you learned something new, and I look forward to hearing about your thoughts on compound probability.